Oh, variables, how I love thee. A variable is there to stand for the unknown, the thing we don't know, the thing that we're trying to solve. So for example, in this first equation, 6 times 3 equals P. Well, P could stand for pizza, presents, pretzels, pumpkins. We don't know what P stands for, but it gives us a clue, just like a subject or an email or a title of a book, what we might be talking about. So in this group, we have 6 groups of 3 peanuts? I don't know, but whatever that P stands for, I know that P equals 18. So I have my equation, my variable, and my solution. And I can start to guess based on what that P stands for. I could start to maybe think that my P could be paper towels. That variable gives us an idea of what we're talking about. In this case, we don't know because we only have an equation, but if it was matched to a story problem, that would be my representation of my L. In my next case, my U is my unknown, my variable, which could be umbrellas or unicorns or ukuleles. But what's kind of cool about equations is I can have my variable or my solution in front. It doesn't always have to be in the back. So in this case, I have 18, which is my whole, divided by 3. I know that 18 divided by 3 is 6. So my U equals 6. And again, so if I look here, I have my variable, my equation, which could be flipped around, my solution, and I could guess my label based on my variable U, which could stand for, let me get my right color here. How about, I'm trying to think of another U word, which is tricky to do. I'm sure you guys are thinking of tons, way more than me. I'm just going to go with umbrellas. But in this case, because there is not necessarily a story problem, in this case, I could just put U equals 6. If there was a story problem that was verifying what my unknown was, then in that case, I would need a label. All right, but because it's just an equation, that works too. So now let's check out some more unknowns. Now in this case, we have our variable or our unknown not at the end. But that doesn't mean we can still figure it out. That doesn't mean that we can't figure it out. So in this first one, I'm going to change my color here. I have 4s equals 12. That means when there's no symbol in the middle, there is an invisible x right there. It's just invisible. The mathematicians, they a long time ago said, you know what? It just takes way too much time to put that x. So mathematicians said, we'll just take it out. But it's there, we just can't see it. So there's an invisible 4 right here. So I have to think about 4 times what equals 12? Well, 4, 8, 12. Skip counting, I know that S equals 3. For fun, I could be talking about snakes, spaghetti noodles, sweatshirts, and S could stand for something in our unknown story. Next one, 49 equals 7b. Remember, if there's nothing there, there is an invisible multiplication. It's hard to write really small on the screen. There's an invisible multiplication in the middle. So it actually says 49 equals 7 times b. So 7, how many 7s? 7 times what is 49? 7, 14, 21, 28, 35, 42, 49. You guys can't see me, but I'm skip counting on my fingers. 7 times 7 equals 49. So B equals 7. B in this case could be bananas, butterflies, barbecues, bats. It could be many different things. Next, 5W, oh, they're smushed together, which means there is an invisible multiplication sign right there. I just can't see it because mathematicians are trying to trick me. 5 times W, or 5W, equals 35. How many 5s equal 35? I'm pretty good with my 5s. So I know 5 times 7. So W equals 7. W, that could be wombats, watermelons, washing machines, many different things. It's kind of fun to infer what it could be. 10D equals 60. In this case, they're trying to trick me because they're trying to put the answer in the front. I know mathematicians can do that, and I also know there's an invisible multiplication sign in the middle. How many 10s equals 60? 6. So D equals 6. 7t equals 56. There's an invisible x in there, so 7 times t equals 56. I was telling, I think it was Jasper and I were working through a problem. This is the hardest fact for me for some reason. But I know 7, if I count up, skip count 7, 14, 21, 28, 35, 42, 49, 56. There are 8 7s that equal 56. So sometimes that variable doesn't always have to be at the end. Sometimes the variable is smushed inside and next to another number. It's still an unknown that we need to find. In this case, our unknown or our variable is in division. So with division, we now need to find the unknown. 12 divided by. So for division, there's never going to be a missing symbol. There always will be something there. There's nothing invisible in division. 12 divided by R equals 3. 12 divided by what number equals 3? So I have my whole. So I need to know how many 3s fit into my whole. 3, 6, 9, 12. I'm skip counting my fingers. You guys can't see me, but I'm skip counting, and I have 4 fingers up right now. 3, 6, 9, 12. So R equals 4. I'm going to make sure that that works. If I put a 4 right here, is 12 divided by 4 equal to 3? Is 3 times 4 12? Yeah, I can kind of think backwards too. If there was a little exploit here, would it work the other way? Yep, it would. 64 divided by C equals 8. So I'm thinking of, here's my whole. How many 8s fit into 64? Skip counting by 8s. How many 8s are going to fit in? Or I can think backwards. 8 times what equals 64? This is a fact I know. So I know C equals 8 because 8 times 8 equals 64. I can work backwards. Next one. Oh, they try to throw a different symbol in me, but this symbol here, right there, it means division. It's a fraction symbol, but it means division. So this equation says 4 equals 32 divided by F. I'm going to switch it around so I kind of read it the way I usually see it. 32 divided by F equals 4. Here's my whole. How many 4s fit into 32? 4, 8, 12, 16, 20, 24, 28, 32. I have 8 fingers up. I just skip counted by 4 into 32. So I know that F equals 8 because 4 times 8 equals 32. Okay, I'm in trouble this time because my whole is missing. So now I can use my trick. I can work backwards. 7 times 2 is 14. 14 divided by 7 equals 2. Let's see, 2, 4, 6, 8, 10, 12, 14. I just counted my 2s, and there's 7 of them that equal 14. So Y equals 14. For this next one, again, my whole, which is my number on top or in front, is missing. So how many, I can work backwards. 3 times 2 equals 6. So M has to equal 6. If my hole is there, like in these, then I can figure out how many of the numbers fit into it. If my hole is missing, like these, I can use my multiplication trick. Go try it.